This is a goodness of fit example that we're going to use to demonstrate how to perform goodness of fit tests on the TI calculator. So suppose we have a random sample of 140 births, and the local records show the following distribution of these births. Using this sample, are births evenly distributed across the week? We're going to use the calculator to input this data and test this claim. Suppose we wish to conduct a chi-square goodness of fit test, and suppose further we do not have a goodness of fit command on our calculator. You may still perform it on the calculator, and here's how you can do it. We'll first enter in our data into L1 and the expected counts into L2. So we hit Stat, Enter, go over to L1, and we'll go ahead and enter in our data. Now we've finished entering in our data, we will now enter in the expected counts. Alright, now that we have entered in our expected counts and we have entered in our data, we may now conduct the test, and we're going to compute the test statistic, the p-value, and the contributions of each specific term in the chi-square test statistic. So we call up L1. We're going to subtract L2, we're going to square these results, and we're going to divide by L2. We're going to store these results in L3. These are the contributions to our test statistic. If we hit second stat and call up sum, we may go ahead and sum these contributions to get our test statistic. So for this problem, our test statistic is 7.6. The p-value is next. And for that, we go under the distributions command. We bring up the chi-square CDF option. We tell it the left bound where to start shading. We give it the right bound where to stop shading, in this case the largest number that can be stored on the calculator, and the degrees of freedom. We ask it to compute this, and we have our p-value at about 0.27. If we wish to have a diagram of these results, we may do so. And first we need to size up our window. So I go under Window, the x-min is 0, the x-max is 15, x-scale will be 1, the y-min I'll set to be negative 0.2, and the y-max I'll set to be 0.2. The y-scale I'll set to be 0.1. And I will go ahead and have it shade chi-square, and again I'll type in where to start shading at 7.6, our test statistic, where to stop shading, the largest value the calculator can store, and the degrees of freedom. And here is our p-value displayed. It gives us the area, that's the p-value, the degrees of freedom to be 6, the test statistic, where you start shading under your distributions to determine p-values, and the upper bound that I typed in. And this is how you can perform a goodness of fit test on a TI-83 or even on an 84 if you do not have a goodness of fit command already programmed in.